Hello everyone, in this video I'm going to teach you what is called a D-test. Before I start the D-test itself, let's just see where we are. As we mentioned several times before in this section, the goal is, well, to find relative max mean of a function with two variables. That's the goal. Still, we are trying to figure out how does that work. What do we know so far? Well, we know that relative max mean, max or mean, happens only on critical points. So we know that also. So critical points are important because those will give us the good candidates to check and see which one of them are local mean, local max, or maybe neither. Okay, so then the next step we want to learn, or we want to learn how can we determine if a given critical point is relative max or mean or neither. So how can we determine if the given critical point is a max, is a mean, or maybe none of them? Okay, so this is something that going to be answered by the famous guy, the test. What does the test say? The test says, well, you need a little bit more information first. Let us assume that AB is a critical point. So it's a critical point. Then, well, we define something out of this function. Then we said, what do we do is this. This you have to be very careful at this stage. So you find the second partial derivative fxx and evaluate it at a, b. You find fyy, sorry, fyy, and then evaluate it at ab. Then find fxy and evaluate it at ab. This last thing you have to score it and subtract from the product of those things. So fxx at AB, fyy at AB minus fxy at AB. So we call this guy D. This is the D you see in the name of the test, D test. But for me, just to emphasize that this depends on the point AB. I sometimes put AB in front of that just to emphasize that there's a relation between these two. Okay, so we set this D, we define that, but then we are not done. We are just at the beginning of the story. How this D is going to tell us which one of the critical points is relative max, mean, neither. Okay, so there are three cases. DAB, why is that sorry, let me just, okay, DAB is either a positive number, DAB is a negative number, and DAB is 0. These are the only possibilities, yes? Either a number is positive, negative, or 0. So if it is positive, we need to do one more step. That more step is that check the value of the second derivative, second partial derivative fxx at AB. Is it a positive number or it is a negative number? Oh, sorry, again, fxx. If it is positive number, so D is positive, fxx is positive, then AB is relative mean. If fxx at AB is a negative number, then AB is relative max. If DAB is negative number, that's another case at the beginning, so this one, then it's neither relative mean nor relative max. It is a saddle point. And what happens if DAB is 0? Well, in that case, D test is inconclusive, meaning that it cannot say anything for sure. It means that that point can be relative mean, relative max, or it can be saddle point, it can be neither of these guys. So the test stops there. You cannot say anything for that specific case. So this is the whole d-test. First of all, you have to make sure that you pick a critical point. When you have critical point, you form this value. We have d for that, yeah, and then you check the sign of the d. So this is checking the sign of the d, but then after that there is one more step to be able to establish the result. Before I finish the video, I just wanted to bring your attention to uh, something that you have seen before. Recall that for a function with one variable, like f of x, if c is a critical point, then we could say when such a c is local mix, local mean, local max, just by looking at the value of the second derivative at that point. This I'm hoping that you remember from introductory calculus. If the second derivative at c is positive, then c is a relative mean, and if the second derivative at c is negative, then c is a relative max. Well, why did I mention this thing here? Well, look at this thing very carefully. In the case of the second derivative, we have the second derivative, if it is positive, it's going to be relative mean. We have the similar thing here. If the second derivative, but well, when you have more than one function second derivative, you have to say some partial derivative. In this case, fxx is positive, then it is relative mean. If it is negative, it's going to be relative max, as it was in the case of functions with one variable. Well, you have to be very careful. This part for the functions with two variables is a very critical point. So you have to first evaluate the value d, and then go for the second derivative. So this is what is called the second derivative test, or D test, for function with two variables. And well, in the next videos, you will see me doing some examples for this and then see how it works.